Yes or no? No, you didn't try, right? Okay, then let us plot. Let us see the last. There were only two questions in this exercise, right? Exercise 6 point, which one? 4.4, sorry. So first question we have discussed, right? If you remember. So we discussed about the role of C basically. Understood? Anyway, let us proceed. Okay, just 1 minute. Let me open my book. So here is the question, as you can see. So give the geometric representation of 2x plus 9 is equal to 0 as an equation in one variable and two variable, right? So if I just first of all consider it as an equation in one variable. So it is given 2x plus 9 is equal to 0. So I don't need the second variable, right? Because I'm considering it in an equation in one variable only. So I'll simply find out 2x is equal to minus of 9 and x is equal to minus of 9 divided by 2, right? Which is x is equal to minus 4.5, right? So when you have only one variable, that means only number line you need. Clear? So there is no Cartesian plane here, only number line. Is this understood? Now, because I have to go in the negative direction, so I can take my 0 here because I don't even have to go on the positive side. So this is 0. And like here you can take 1 and 2, 3, 4, 5, 6 like this, right? So your number is where it is minus 4.5, right? So it lies between 4 and 5 in the sorry, it will be all minus, not positive. So they're all negative numbers here. 4.5, that means between 4 and 5. So it will lie here, right? So this number is minus 4.5. So you have shown it on a number line. Clear? No response, right? Okay. Now in two variables, if I want to consider it in two variables, how will I plot it? Please unmute your mic, both of you. Yeah. So that is your equation which is given. There is no y. So I can add a y, right? How I can add? I can write it 2x plus 0 into y. Any problem? Because ultimately it will be 0, right? So you can see now two variables, right? Okay. So I can find the value of x because y is actually multiplied with 0. I cannot find the value of 0. Sorry, y. So let us find the value of x from here. So 2x is equal to, now take it other side. So it will be minus of 0y and minus of 9, right? Everything I have taken on the other side. Clear? So your x will be minus of 0y minus of 9 and divided by 2. Is this clear?
Yes, ma'am.
Okay. Now you start taking some values of y and then find the corresponding values of x. Okay. So 0. Now any number you can multiply with 0, it will ultimately become 0. So you start with y is equal to 1, right? So what will you get? X is equal to 0 into 1, like minus 0 into 1 and minus 9 divided by 2, right? So ultimately first term is 0. So it is only minus 9 by 2. So you get minus of 4.5. So your x is minus of 4.5, right? Okay. Now you can take y is equal to 2 next. Y is equal to 2. Let us see. So x is minus 0 into 2 and then minus 9 divided by 2. Again, the first term is 0. So it is again 9 by 2. It is minus of 4.5. So again, you get minus of 4.5, right? Or you take next, you take a negative value. Let's take it minus of 4, right? Let us check. So x is equal to minus 0 into minus of 4, right? And then, sorry, minus 9 divided by 2. So 0 multiplied by anything is anyway 0. So 0 minus 9 divided by 2, which is minus 9 by 2 is again minus 4.5. So again, you get 4.5, right? So you can check whatever value you take, ultimately you are going to get minus 4.5. Is this clear? Now,
Yes, ma'am.
now because I have two variables, so I'll use a Cartesian plane to plot it, right? So let us draw a Cartesian plane quickly. And my x is negative, so I'm going to go, sorry. Anyway, very roughly I'm drawing it. You can, and please use a graph paper for this chapter, otherwise there's no use. In the exam, you have to use graph paper. And right. So this is your x-axis, this is your negative of x-axis, this is your negative y-axis, and that's your positive y-axis. So just look at your values. 1, 2, 3. Anyway, I don't have positive values. I have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, like that. And y 1, 2, 3, 4, and minus 1, minus 2, minus 3, like that. Minus 4, minus 4, right? Now look at your points. So y is 1, it's here, right? And x is minus 4.5, that means in this direction. So it is like in the middle. Clear? Understood?
Yes, ma'am.
Okay. Again, y is 2. So here and then again here. So again in the middle here is your point. And y is minus 4. So this is minus 4. So again, x is this the same. So ultimately, you are going to get a line here, which is, sorry, it's not. So if you join these points, sorry, my line is actually not falling on the point, but anyways, the points will lie on the line. Let me just draw it properly for you. Sorry, I don't know what is happening. It's difficult to draw here. Let me just draw it roughly, okay? This is the line, straight line. So every point you can see, either it is y is equal to 1, so x is minus 4.5, right? Y is equal to 2, your x is minus 4.5. Y is minus 4, then also x is minus 4.5. So all the points will fall on this line. So this line is parallel to y-axis. Clear?
Yes, ma'am.
Yes. Now, can you just try to analyze it a little bit? Why I'm getting this 4.5 difference here? If I just go back to first question of the exercise, right? Yeah. If you remember, this was the question, y is equal to 3, correct? That means every point will have a y is equal to 3 value, right? So there is a line like this where y is 3, positive 3 for every value of x. Clear? And if you again go to like examples I was giving you, yeah, this question, if you remember, so I use this, right? X minus 2 is equal to 0, right? Can you see this? So ultimately x is equal to 2, right? This means x is equal to 2. So you can see on this line, everywhere x is equal to 2, right? For every value of y, your x is actually equal to 2. Clear?
Yes, ma'am.
Okay. Now you look at your equation. So your equation is 2x plus 9 is equal to 0. So here basically the coefficient of x is not 1. So we can make it 1. We can take a 2 common from here, right? So it becomes x, or if you don't understand common, just divide this by 2, right? So divide both sides by 2. So 2x plus 9 divided by 2 is equal to 0 by 2. No problem. So 2x by 2 plus 9 by 2, and 0 by 2 is actually 0. So this becomes x plus 9 by 2 is equal to 0, right? So now I have got my coefficient of x is equal to 1. So now if I find its value, it becomes x is equal to minus 9 by 2, which is actually equal to uh, x is equal to minus 4.5. So you can see on your line also, every value of x is minus 4.5. Is this understood by everyone?
Yes, ma'am.
Okay. So I hope you have understood this chapter, and now please note, next class, which is on 29/09, I'm going to take a test of linear equation in two variables. Fine, Zeba? Jocelyn?
Yes, ma'am.
Okay, so please prepare it. Now let us start a new chapter, congruent triangles, or triangles I call it. Yeah, that's the chapter. So NCRT calls it triangles. So basically, so far you know about angle sum property of a triangle. We have discussed it in the chapter lines and angles, correct?
Yes, ma'am.
Jaslyn, were you there when I was doing the chapter lines and angles?
No, ma'am.
No, you have not done the chapter. Okay, and Zeba, I think you were there, right? Zeba,
Yes, ma'am. Even
have
I was in the
you were there?
no.
Yes, okay. Yeah, I think Jaslyn joined a little bit late. Anyway, Jaslyn, in this batch, I have actually covered lines and angles, but I'll just go through the chapter again. Okay, I'll give it a revision after triangles. So far, you can just note down because we might be using it. So if you have any triangle, uh, any shape, it's not necessary that it's an equilateral triangle. It can be of any shape, A, B, and C, right? So the angle sum property is that sum of angle A, that means this angle, and angle B and angle C, plus angle B plus angle C is equal to 180 degree. That means this is a theorem that always the sum of the three angles of a triangle is 180 degree. That's it. So far you can just remember this thing, right?
Okay.
Now, in this chapter, you basically have to study congruency. Uh, Congruency or congruent triangles. First of all, let us try to understand the meaning of congruency. What is the meaning of the word congruent? If I have two geometrical figures, let's say I have one coin, right? And then I have another coin. Now, if I just place this coin over the other, it should exactly cover the other point, right? Understood? If it exactly covers the other figure, then we say that these two coins are congruent to each other. So we can say congruency means two geometrical figures, please note it down. Two geometrical figures are said to be congruent. Are said to be congruent if they have exactly same shape and same size, right? So you can underline this thing, same shape and same size. So these two are like important words here. Obviously, same shape means if I have a circle and I have a triangle. I want to place the triangle over the circle. So obviously the triangle is not going to cover the whole area of the circle, right? So I need a circle to cover the circle. Okay. And if the radius of the circle is unequal, let's say one circle is having a radius 4 centimeter, another circle is having a radius of 5 centimeter. So if I place this circle over this circle, so obviously it's not going to cover the full area of the circle, correct? So they are not congruent. So, and these figures are also not congruent. The congruent figures can be this: if I have a circle whose radius is 4 centimeter and I have another circle whose radius is also 4 centimeter. So you can see shapes are also same, size is also same, so they are congruent, right?
Yes, ma'am.
Okay. Now what is congruence? So congruency of shapes you have understood. Now what about congruency of angles? So just understand it. It's not like something very important. I have an angle and I have another angle. So if I place like these two arms over these two arms, so they exactly like superimpose each other, right? So then we say that these two angles are equal, or we say um, they are congruent. Understood?
Yes, ma'am.
Okay. I mean, the measurement is same. If it is also, let's say, 65 degree and this is also 65 degree, so they are congruent. So it's not such a difficult thing to understand. I think congruency is clear in your mind.
Yes, ma'am.
Yes, ma'am.
Okay. So we have to study specifically the congruency of triangles here, right? Not other figures. Okay. So just write down one thing. So in case you forget. So the two triangles are congruent. Mm, or you write it like this, like make two triangles. Okay. I think this is your triangle ABC. This is your triangle PQR. Okay. So the triangles, okay, if, right, this side, AB side is exactly equal to side PQ, correct? And BC side is exactly equal to QR. All right. And this third side AC is exactly equal to PR. So AC is equal to PR. So if all the three sides, like corresponding sides of two triangles are equal, right? And angles. Now, if this angle is same as this angle. That means angle A is equal to angle P, right? And then this angle is equal to this angle. So angle B is equal to angle Q, correct? Okay. And then the third one, like angle C is actually equal to angle R. So angle C is equal to angle R. Now, if these two conditions are satisfied, then we say that triangle ABC, right, is congruent to triangle PQR, right? Now, please note one thing again important here. See, I cannot write it QRP or like QRP or QPR. Why? I have to write it correspondingly. So as you can see that angle A is actually equal to angle P. So if I'm writing A first, so I'll write P first. Okay. Then angle B is equal to angle Q, right? So in like correspondingly, if I'm writing B here, so I'll write Q at the second place. I cannot read it like this. I mean, I'll not write PRQ. Is this clear, everyone?
Yes, ma'am.
So correspondingly,
Yes,
you
ma'am.
have to write. Now, because angle C is equal to angle R, so they both should come in the end. So naming is like important. So you should name it correspondingly. So this is the sign of congruency, right? So if this sign is there between two triangles, that means they are congruent. And if the triangles are congruent, so it means these things, that corresponding sides are equal and corresponding angles are equal. Understood?
Yes, ma'am.
Okay. Now, see, in actually every time, like in real life, it's not possible that you pick one figure and place it over the second figure and see whether it is congruent or not congruent, right? For example, triangle. Let me say we have two swimming pools in different homes. I want to check whether they are congruent or not. The swimming pools are in the shape of triangle, let us assume. So it's not possible that I pick up one swimming pool and place it over the other, correct? So obviously I'm going to take their measurements and then I'll see. So there are conditions, there are criteria. If some criteria are satisfied, we say that the two triangles are congruent. Understood? So let us learn
Yes.
one by one what are the criteria for congruency. So you write down sufficient conditions or criteria. For congruence of triangle, congruency or congruence of triangles, both are correct, right? So let us see conditions one by one. So first condition we will learn is called side angle side. In short, SAS. Okay. Criteria. Now, what does it mean? So I'll tell you what to write. Now, please understand. It means that if you have two triangles, so A, B, C, and if I call it, let's say D, E, F, right? Okay. Now here you can see there are two sides, right? And only one angle. Now there's a condition that if you are taking this side, that AB is equal to DE, right? And the other side is this, AC is equal to DF. Now the angle which is falling in the middle, I mean this angle you have to consider. Understood? Not angle B, not angle C. All right. So basically if this is happening, that in two triangles, my side AB is actually equal to DE. All right. And my side AC is actually equal to DF, right? Then if angle A is also equal to angle D, if these two angles are also equal, so I'm not bothered about these angles, understood? I need this angle only, which is falling between these two sides, understood? If these three conditions are actually satisfied, so we say that by SAS criteria, triangle ABC is congruent to triangle EDF, correct? Oh, sorry, not EDF. D, sorry, wait. A is actually equal to D, so I'll write D, uh, DEF, ABC and DEF like that, right? Is this understood?
Yes, ma'am.
Okay, so you just write down about this criteria. So two triangles are congruent if two sides and the included angle. Okay, so you understand now what is included angle? The angle which is actually falling between the lines. Okay, included angle of one are equal to the corresponding sides and the included angle of the other triangle. Now please read this sentence again. Right? So two triangles are congruent if two sides, right? And the included angle of one triangle are equal to the corresponding sides and the included angle of the other. So they are congruent, right? So this is actually a theorem, I mean, but the proof is not required for exams, okay? So you just have to know what is SAS criteria. So we are not going to do its proof. Just 1 minute, let me open your book. Oh, sorry, this is class 10. Yeah, here. Okay, let us do exercise now. Just 1 minute. I'm just looking out one thing. Ah, I think we should do all the criteria first of all, and then we will do exercise. Okay. So there's next criteria, and then we will start exercise. Now, second criteria, please note down. This is called angle side angle, and we call it ASA criteria. Right, Jocelyn?
Yes, ma'am.
Okay, so here you can see that by the name also you can see ASA, that means two angles will be equal and one side will be equal. Understood? So you note it down first of all, then we will have a discussion on it. So two triangles are congruent if two angles and the included side of one triangle are equal to the corresponding two angles and the included side of the other triangle. So again, right now I'm not doing the proof. Just try to understand what is the meaning of it. Uh, so it is again saying two triangles are congruent, right? If two angles and the included side, that means if again you have a triangle ABC, right? And then you have a triangle PQR. So two angles and the included side. So for example, my angle A is equal to angle P, right? And angle B is equal to angle Q, right? Now, which side is included here? I mean, the side which is actually falling between the two angles. This has to be equal. And this side, AB, is equal to PQ. So if this criteria is satisfied, so I say that like by ASA criteria, triangle ABC is congruent to triangle PQR. So you can just write it down, making this a small figure. So this has to be satisfied. Right? Done?
Done, ma'am.
Third also. Please write down third criteria also. There are four criteria basically. So first of all, I just want to write down all three and then we will do exercise. So the third is angle, angle, side. So AAS criteria. So first write it down, then I'll explain it. If two, they are all actually theorems, right? So I'm not just going into the proof right now. We will do it later, but here main thing is you understand them first of all. If any two angles and a non-included side of one triangle are equal to the corresponding angles and side of another triangle then the two triangles are congruent. All right. So write it down, then I'll explain it. Now try to understand. This is AAS, right? So look here, if any two angles, right? Any two, please underline, any two angles and a non-included side. So please underline non-included side. So that means if you have, again, you have two triangles, let me say, take it ABC. And also note one thing, see, please pay attention here. Like I always draw triangles like this. It's not necessary that it has to be like this. It can be a triangle like this also. Understood? Or it can be a triangle like this also, right? Any shape of triangle can be there. So don't think that it is always an equilateral triangle. Is this understood?
Yes, ma'am.
Okay. So let me draw a little bit like this. So if this is one triangle and this is another triangle, same shape, same size. Now A, B, C, P, Q, R, or D, E, F, whatever you want. Now any two angles, right? So for example, my angle A is equal to angle D. Angle A is equal to angle D. And it is coming out that angle B is equal to angle E. Angle E. So what is the difference here? Previously, it was ASA, right? That means the side was the middle size. I mean, the included side. Understood? Now, this time you can take non-included side. So I don't want AB. BC is equal to EF, right? Or AC is equal to DF. So if BC is equal to EF, only these three conditions are satisfied. So we say that by AAS criteria. So if S is written like right hand side, that means it is the non-included side. Jaslyn, understood? If I write like this ASA, that means this side is the included side, right? And if I write AAS, that means this side is the non-included side. Is this understood?
Yes, ma'am.
Okay. So this is called the AAS criteria. Like if these three conditions are satisfied, so we say that triangle ABC is congruent to triangle DEF. Please write it down. So far, how many criteria we have seen? SAS, right? Two sides and the angle between them. Then two angles and the side between them, correct? So SAS and ASA. Now this is the third one, AAS. That means S is not the included side this time. All right. right? If you have written, I hope you have written. There is a fourth criteria also. So right now, I'm not going into the proof of it. Okay, that we will do later on. Here, I'm just introducing you to the various criteria. Is that okay? So the next is side, side, side. Okay, or we call it SSS criteria. Understood?
Yes, ma'am.
Okay. So this is simple, right? By the name itself, you can say that if all the three sides of the triangle are corresponding sides are equal, uh, then they are congruent. So just write down two triangles are congruent if the three sides of one triangle are equal to the corresponding three sides of the other triangle. So if I have two triangles, A, B, C, and another triangle PQR. So if this is happening, that AB is equal to PQ. Now, when I put a dash here, look here. If I put a single dash, that means this side is actually equal to this side, right? And double dash means this side is actually equal to this side. So the side which have double dash, that means they are equal, right? The sides which have single dash, that means they are equal. I cannot say that AB is equal to QR. Is this understood?
Yes, ma'am.
So from the dash, I will identify that it is having a single dash, it is having a single dash or bar. So that means AB is actually equal to PQ, BC is equal to QR, and if the third side AC is equal to PR. So that we identify like this. We put three bars here, right? So that means AC. Now, if these three criteria are satisfied, so we say that by SSS criteria, the triangle ABC is congruent to triangle PQR. This is the fourth criteria of congruency. Okay. There's a fifth one also. I think I should give you the name also. Then we will do the proof later on so that we can just finish at once whatever criteria are there in the chapter. So this is the last one. It is called right angle, hypotenuse, side. Okay. So in short, it will be called RHS criteria. So this is only for a right angle triangle. Okay. Because you can see there's a right angle here and a hypotenuse. So what does it say? It says that, if I can explain it here, or you first write it down, then I'll explain. So two right triangles are congruent if the hypotenuse and one side of one triangle are respectively equal to the hypotenuse and one side of the other triangle, right? Okay. Now note down the important terms here. First of all, right triangle. Okay. So both the triangles have to be right triangle. So if I have a triangle, let's say ABC, so one angle has to be 90 degree. A, B, C, then you have another triangle, P, Q, R, right? So now read again. Two right triangles are congruent if the hypotenuse of one side, hypotenuse and one side of one triangle. That means its hypotenuse is equal to this hypotenuse, right? Now, which side is hypotenuse? The which is opposite to the 90-degree angle, right? The longest side of the triangle. Okay, and one side. That means any other side. Let me take BC is equal to QR, right? So because already they are both right triangles, so we are not like saying that one angle is 90 degree because we have already used the term right triangle. That means obviously one angle is 90 degree in both. So basically one angle is matching here, okay, which is 90 degree. Then length of the hypotenuse is same and any other side is same. So if these three criteria are satisfied, so we say that they are congruent. So if angle B is equal to angle Q, which is actually equal to 90 degree, correct? And then hypotenuse, which is AC is equal to PR, and then any other side, which is BC is equal to QR. So if these criteria are satisfied, so we say that by RHS criteria, now triangle ABC is congruent to triangle PQR. So be careful. Now B is the 90-degree angle. So here Q is the 90-degree angle. Both are written in the middle. Okay. I hope you have understood the criteria so far.
Yes, ma'am.
Okay. So please note it down. I'll take at least one question from the exercise. Yes, hello.
Yes.
Oh, see, my mic was mute, but you couldn't tell me, right? I just noticed my mic was on mute. At least you should tell me that. All right. Now, is this clear to all of you? Now, see again. Now, see, is this clear what is given in this question? So it is given that AC is equal to AD, right? And AB bisects angle A. So that means if I call it angle 1 and call it angle 2, so angle 1 is actually equal to angle 2. This is given. And we have to show them congruent. So we take whichever triangle you have to show congruent, you have to first of all take them. So in triangle ABC and triangle ABD. So we write like this. Okay. Let us see what things are equal. So AC is equal to AD, which is already given to me. Clear? One condition I got. And angle 1 is equal to angle 2, which is again given. Correct? Now you can see the side AB is part of both the triangle, right? So one triangle is this, which is ACB. And if I just divide it, so can you just see this? So AB is basically the part of both the triangle. So it obviously it has to be equal. So as you can see, this side, and the middle angle is equal, correct? So which criteria? SAS. Understood? So by SAS criteria, we write that triangle ABC is congruent to triangle ABD, correct? See, because B is part of both the triangles, so it is in the middle, so it has to be in the middle here, right? So ABC, ABD, same way you have to name. So first of all, we will see whatever things are equal in the triangle, and then we will see which criteria does it satisfy. So we will name that criteria. So basically we are using this theorem, okay? So by this theorem, we can say that the triangles are congruent. So anyway, I'll stop here. Just go through all the criteria and then we will be doing exercise 7.1 in the next class. No, in the next class, I have announced a test, right? Remember? Okay, please unmute your mic, Seba and Jaslyn. Okay, not in the next class. I think on Saturday, right? 29/09/22. I will be taking a test of, I think I just told you, right? Isn't it? Linear equation in 2 variables. So be prepared for the test on Saturday. Clear? Can I hear something? Yes or no? Unmute your mic, please. Sorry, Saturday is not 29.